One of our main inferential tasks is to do a confidence interval to say what are some other reasonable values we could have observed, and we're going to do that in the situation where we have a difference in means. We have two means. Our generic confidence interval is, as always, our point estimate. That's our sample statistic, our best guess. And then we're going to add and subtract some variability. And what we're going to add and subtract is a critical value times a standard error. And in this case, our point estimate is x1 bar minus x2 bar. Our critical value is going to come from a t-distribution, and then we're going to multiply by the standard error. And as long as n is large, so both n1 and n2 are at least 30, then we can use that t-distribution to approximate the sampling distribution. So let's just look at that. We've got our point estimate plus or minus our margin of error. That's the critical value times the standard error. Here's our formula for the standard error, where we're going to take the standard deviation of the first group and square it over the sample size of the first group, plus the standard deviation of the second group squared, and we're going to put that over the sample size of the second group, and then we're going to take the square root of the whole thing. And again, we're going to use the t-distribution with the degrees of freedom, the smaller, the minimum of these two numbers, the degrees of freedom for the first group and the degrees of freedom for the second group. So let's do an example. This is from my general social survey data, and we've got 200 respondents. So in this case, n is equal 200. And we have the average number of hours worked by a self-employed person is 37.5, and the average number of hours worked by a person employed by someone else is 41.5. And then I've got the standard deviations for both groups. And then it says there were 28 self-employed people in the sample and 172 employed by someone else. And we're going to find a 90% confidence interval. So I'm going to write out some of the stuff from the paragraph in terms of notation. So I've got x bar 1, that's the mean of the first group, that's 37.5. I've got x bar 2, that's the mean of the second group, that's 41.5. Then I've got S1, the standard deviation of the first group, that's 17.5, and the standard deviation of the second group is 13.6. We have the overall n, but let's say n1 is equal to 28 and n2 is equal to 172. Okay. So now we've got what we need, and let's just think about these things: the point estimate, the critical value, the standard error, check the conditions, make the interval, and interpret, and we'll do all of those. So our point estimate is going to be the x1 bar minus x2 bar. So that's going to be the 37.5 minus 41.5, or -4. And you could have done the subtraction in the other order if you wanted to. The most important place to remember which order you subtracted is when you do the interpretation. So we've got our point estimate, then we've got our critical value. And this is going to be a t-star value. It's going to come from a t-distribution. And the t-distribution is going to have the minimum of n1 minus 1 and n2 minus 1 degrees of freedom. So that's going to be the minimum of n1 minus 1, that's going to be 27, and n2 minus 1 is 171. The minimum of those two numbers is 27. So I'm going to look at a t-distribution with 27 degrees of freedom. And I'll go to StatKey to do that. So here I am on StatKey. I'm going to look at the theoretical distribution section, and I'm going to click on the t-distribution. And it asks me, what are your degrees of freedom? My degrees of freedom are 27. Okay. And then I can click this two-tail button to get the critical values. This is for a 95% confidence interval. Let's go remind ourselves what kind of interval we're trying to do. So this was a 90% confidence interval. So I'm going to need to change that 0.95 in the middle. I'll click on it, and change that to 0.90. Okay. And then there's my critical value, 1.703. So T star is going to be 1.703. And now let's compute the standard error. So that's going to be the square root of S1 squared over N1 plus S2 squared over N2. I'm just going to plug in from what I have written above. So I've got the square root of 17.5 squared over 28 plus 13.6 squared over 172. Now I'm running out of room, so I think I'm going to move some things to my next page so that I can look at them there. Now I have a little more room. So we found the point estimate, that was the -4. We found the critical value, 1.703, and now we're working on the standard error. And maybe I'll do square those numbers first. So let's see. 306.25 over 28 plus 184.96 over 172. That'll be 10.94 all round plus 1.08 all round. So that'll be a square root of 12.02 or 3.47 all round. That's our standard error. We've got that. Now we're going to do the interval. So the interval is always the point estimate plus or minus the critical value times the standard error. And in this case, it's going to be -4 plus or minus 1.703 times 3.47. And I'll start by doing that multiplication. So it's -4 plus or minus 5.91. So -4 minus 5.91 is -9.91. And -4 plus 5.91 is 1.91. So that's our interval. Okay, oh, we also need to check conditions. So this is, we need N1 greater than or equal to 30 and N2 greater than or equal to 30. N1 was 28 and N2 was 172. So the 172, that's good, but the 28 is actually not good. So the conditions are technically not met. Maybe we shouldn't be doing inference using this t-distribution. Maybe we should be doing the bootstrap instead. And I'll show you that method as well. So maybe we shouldn't be doing this, but we're going to do the interpretation anyway, just so that we can practice our sentence. And it'll go, I am 90% confident that the true difference in mean hours worked between self-employed people and those who work for someone else is between -9.91 and 1.91 hours. So this is a confidence interval that crosses 0. I think you've seen some examples of this before, and that basically means we're not very confident. It's between, we think that people who are self-employed work about 10 hours less, all the way up to we think that they work about 2 hours more. So we really don't know who works more or less because 0 is in that interval. If we ask what are some other reasonable values we could have observed, we observed -4, so it looked like people who were self-employed were working less. They had a smaller mean by 4 hours per week. But when we built that confidence interval, it included 0. So we don't actually know who works more. We're not super confident about that. So that'll be my interpretation. So I said that maybe we shouldn't have done inference using a t-distribution. Maybe we should have done a bootstrap approach. So I'm going to go to StatKey and just show you how that would work.